this assessment, we're asked to design a separation scheme or a flow chart for a separation scheme to separate a neutral alcohol from a neutral carboxylic acid. The assumption is we've got, as the final product in our reaction, a mixture of these two. I'm going to abbreviate the alcohol as ROH and the carboxylic acid as RCO2H for the entire video. Now, the first thing we're going to want to do is dissolve both of these in ether, some organic solvent like ether. And because both are neutral molecules, they're going to be soluble in ether. So let's imagine, in fact, we can draw a SEP funnel here to show that we can put these both in ether. So we'll have our solution in ether. So this is an ether solution, diethyl ether, of the alcohol and the carboxylic acid. Now, we haven't started separating them yet. Obviously, we've just added a third thing to it. But what we can do, we know that carboxylic acids can be made more water soluble by deprotonating. So if we take this carboxylic acid, it's going to have a certain solubility in water. In this case, in the case of the example that we're using here, it's not soluble in water, but if we deprotonate it and make it ionic, it will now be soluble. So we're going to add to our mixture a solution of sodium hydroxide in water. That's going to be more dense than our ether layer. And so what we'll end up having is an ether layer up top that should have only our neutral alcohol, and a water layer at the bottom that is going to have only our carboxylate ion. So we've deprotonated, and so we'll show that as the sodium carboxylate. Not super clear there, but we've got the ionic carboxylate dissolved in water, the neutral alcohol dissolved in ether. Well, with using our SEP funnel, we can now separate them to where we have a flask that contains only the alcohol in ether and a flask that at least temporarily has only the carboxylate in water. Well, if we take this and evaporate the ether, we now have the pure alcohol. So we've at least succeeded in one thing of getting the alcohol. The question didn't ask us how do we separate the carboxylate, though. We want the carboxylic acid. So let's throw this back into our SEP funnel. Ooh, not looking like much of a SEP funnel there. Throw that back into our SEP funnel, and it's going to start with being in water, our carboxylate. If we add to it ether and HCl in water, what's going to happen? Well, we're going to neutralize all of the sodium hydroxide that was there. We're going to neutralize the carboxylate, and we'll now have a biphasic mixture again, where we have water on the bottom, ether on the top, but because we've protonated our carboxylic acid will be neutral again, and will be sitting in the ether layer. Our water layer will be empty, or will have nothing of interest in it. We can now do the same type of separation, putting our carboxylic acid in a flask with ether as the solvent, evaporate the ether, giving us pure carboxylic acid. We've separated the alcohol and the carboxylic acid.